This video and the next series of videos are going to introduce you to big data, and then we will go into a discussion of NoSQL, which was really invented and given rise uh, during the advent of big data. So first of all, we'll just talk about what big data is, and then we'll move into the more specific details about NoSQL. So a little bit of a comment here, but uh, big data, this doesn't really apply. It doesn't really mean that the ones and zeros are larger, but what does it mean? So um, when we think about relational database systems, our major use case for those systems are the day-to-day business operations that we see in our daily lives. We interact with Amazon. Amazon um, produces transactions, but on a smaller scale, if you're talking about a company or a um, just a small business or something like that, they are producing data day to day, and those data points are collected and stored in a regular relational database system. And we've already talked about in this video series the idea of um, taking the data from a relational uh, production database and then moving it into a data warehouse. So a lot of the things that are going on in the database research world are moving toward this idea of big data. Relational databases have been around for a long time. 1970, I think, was the original paper where a relational database was um, first suggested. So they've been around for a long time. There are query languages that are very robust and very well known, like SQL. And there are lots of research also in query optimization to make them as fast as possible. But when we consider the way the internet has changed over the past few decades, we started with an internet of simply computers. And the internet of computers came about when businesses needed those transactions to be recorded, to be collected, to be stored in a way that they could get to those transactions very quickly. But as time went on, what actually started to happen with the inventions of websites like MySpace and then after that Facebook, what we really became was an internet of people. So the scale was now different. Rather than individual computers that were connected to a network, now we're actually in a time of social networking where marketing and advertising to individual people is now possible, and also marketing and advertising to their friends. But the data that is behind that is extremely important. The last thing that we see, the last trend that we have started seeing, is now we're moving to an Internet of Things, where not only are we connecting people, but we're also connecting devices. And a lot of people have various devices that are connected to the internet, and they actually describe more information about a person than what we would normally have. So looking at things like networks of interconnected objects, such as cameras and cell phones, lighting, smart plugs, all these things, even these health devices now, they're all interconnected, so we are becoming an Internet of Things. And because of that, the data that we've collected, the amount of data, has really, really grown very quickly and at an unprecedented rate. The size of the data collected exceeds the capacity of most of the relational database management systems that we have in place. The data collected now, especially with Internet of Things devices, is not normally structured. So we have all this data from all these different sources, and then that data itself is in various formats. So really it's unstructured data when we look at it as a whole. The other thing is that data is generated in real time. Um, there is not much in the way of batch jobs anymore, and I'll talk about that in a little bit. But thinking about the way that these devices are connected, they're always connected and they're always producing data and information for us to store and deal with. And because it is unstructured and because it is also real time, we probably don't have the ability to define a schema that will be applicable to all the types of data that we're collecting. So the types of data include pictures, video, cell phone data, social media posts, sensor data. We have sensors all over the place now that are collecting data and storing data all the time. Purchase transactions. Every time we look at something on Amazon, or every time we look at something on a site like Wayfair or some of those things, they're collecting data, and they're probably using that data to target us in their advertising campaigns. So this slide has a video connected with it, and I will link this video here on the side of the screen so that you can access that video when you're watching this, and I'll also post the link to the video in the description below. But what it describes is how data is actually used by different places and different companies. But the last statistic that I saw about this came out in 2012, and it suggests that 2.5 quintillion bytes of data is generated each and every day, and that's in the exabyte range, each and every day. There's also another statistic that says that 90% of the world's data was generated since 2012. That's 8 years. 8 years. In the past 8 years, the world's data, 90% of that data has been generated since that time. The global data volume was predicted to grow exponentially between 4.4 zettabytes and 44 zettabytes between 2013 and 2020, and that's per the International Data Group. So you see a very fast exponential growth of data in the world. And obviously, the ability to handle that data has forced us as computer scientists to use new approaches to that data management and query processing that we never had before. Some other examples, and these may be older statistics, but Facebook collects over 500 terabytes of data each and every day. Netflix, 30 million plays per day of movies. But at the same time, Netflix also tracks when you pause, when you rewind, when you fast forward, so that they can better understand who's watching and how they're watching the videos that they present. It also handles 3 to 4 million ratings and searches every day. If you remember, not too long ago, Netflix moved from the 5-star ratings to a thumbs up, thumbs down system. So they're tracking those ratings and all of the searches that are created there. IBM Watson is a it's really an artificial intelligence system that played Jeopardy in 2011, and during its play of um, Jeopardy, it accessed 200 million pages of data on 4 terabytes of disk storage, and it ended up winning Jeopardy with that knowledge. So the next thing I'd like to do is start defining big data from a more holistic standpoint. The first thing is looking at what's been termed as the V's. These are characteristics of big data, and we see these particular V's all around. So the first one is variety. The sources of data where we're collecting data from are very, very different. They could be from multiple sources. They could be from sources that have different types of data storage platforms, but they are all very different. The second thing is the velocity. The speed of data production has increased, as we said, exponentially, and it will continue to do so. That creates a problem of volume. The amount of data that we have is just extraordinarily massive. And finally, veracity. We don't really know if the data that we're looking at is correct or not. These are termed the 4 V's collectively, but others have added some other V words to this, including value, which is the knowledge and the insight that we're gaining from the data is very important, and it's very important to businesses these days. The other thing is variability. The data that we have is not consistent. Various sources of data lead to various types of data storage. So if we consider 3 of these main V's, looking at data velocity, data volume, and data variety, if we focus in on the center of this diagram, we notice that the smaller and smaller sets of data were handled with tables. They're on the megabyte scale. And when we deal with data, we're doing batch updates to that data. As we expand outward from that center point, we have gigabytes of data in the data volume that are updated periodically on the database scale. Moving out further, we have data in the terabyte volume that is updated in near real time, things like photos, web accesses, web data, and audio data. And expanding again, we have the petabyte scale in the data volume that is updated in near real time or exactly real time with social interactions online, video, unstructured data that we're getting from sensors and things like that, and all the mobile data that we are accessing. So big data is growing in this kind of concentric circular pattern where we have in the center of this, that's the very small scale, and it increases as you go out from the center. So the definition of big data, really, it tends to refer to using data analytics techniques that derive from data sets, derive value from data sets. It almost never refers to the actual size of the data. So Charles Fox, in a book called Data Science for Transport, describes big data as where parallel computing tools are needed to handle data. And he goes on to say that it represents a distinct and clearly defined change in computer science, in the computer science used, via parallel programming theories and losses of some of the guarantees and capabilities made by Codd's relational model. And he's referring to that idea where the relational model is no longer the standard way of doing things. So this is kind of an introduction to big data, and we'll proceed with some more specifics in the next video.